Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, selamat tengah hari kepada semua murid-murid SMK Komun Bukit Nenas dan juga kepada murid-murid yang boleh mengikuti live channel MX ni ya. Okay guys, minta maaf lambat sikit sebab I baru saja habis semayang. Oh, plug habis. Alright, lupa switch on plug Okay, so as we know that this is the third week already. Okay, the third sorry, it's not the week, the third phase of our MCO. So kita terpaksa buat kelas juga online macam ini since kita belum boleh balik ke sekolah. Jadi dan hari ini my objective for today is I want to introduce to you, okay, our title for today is Introduction to Vector. Okay, I will discuss all about vector today. Okay, tapi I tak akan cerita tentang contoh soalan, whatever, because my objective for today video is about vector. Apa itu vector? What's the important things about vector? The basic things, okay, the operation, and etc. etc. Example soalan, we will discuss the example question or SPM question on the next video. Okay, on the next class kita akan discuss. So for today, I try to finish this whole chapter by one video. Okay, I will give you the shortcut and also the simplest explanation about the vector. Okay, please kalau you guys rasa membantu, tolong share pada kawan-kawan yang tak sempat ikut kita punya live. Okay guys, so vector, alright. So since you don't have notes, right? Okay, with you, so please refer to your, maybe you have a revision books, okay, or maybe you guys have a whatever notes that you get from your own tuition. Okay, you boleh refer to your notes. Okay, I just want to explain the whole thing. Okay, so now let's say, okay, what is important about vector? All right, so now when we talk about vector, firstly is, okay, so vector, actually you learn this tajuk vector in physics, right? Okay, you already learn this makcik vector. Okay, so according to the definition of vector, it must have two things. Number one, it must have the magnitude, and the second things about the vector, it must have the direction. Okay, so vector actually is defined by these two makcik here. Okay, vector means magnitude, and also to complete the definition of vector, it also must have the direction, right? So normally we know that magnitude, normally we can call as a length. Okay, so we can call as a length. And how we draw, okay, how do we draw the vector? Okay, sangat mudah. So vector is about from one point to another point. Okay, that's all about direction. And then in that direction, we also can count how long the line. So that's why I call the vector as a magnitude. Okay, as also as a magnitude definition. Okay, so now let's say I have this vector. Okay, now you see I have a line here and an arrow and also huruf A and cacing bawah itu. Okay guys, vector A cacing here is a vector unit. Okay, it's a vector unit. This A also is a magnitude. Okay, what is the direction? You see this arrow is the direction. That's why this whole thing we call a vector. Okay, value, the magnitude of vector can be varies. It can be A, it can be triple A, it can be 3/2A, whatever. So how to find that value? Okay, let's say this is our A. Okay, I don't have the graph paper. Okay, tapi tak apa, I lukis saja kat sini. This is my A. Okay, let's say I have like this. You see here, from here until here, this is almost double, right? This is almost double from my previous gambar, right? So this one we can labeling as 2A. Okay, we can label as 2A cacing. Okay, you see the direction, they are same, still similar direction. Okay, let's say I have this one. Okay, so try to compare all these three lines. Okay, the first one is a vector A. You see the direction from left to right, we call as a vector A. The second line is from left to right also, the direction, but the length of the line is double from the previous. So that's why we can call, when we talk about double, that means it's a 2A. Okay, if you look at the third line here, okay, you forgot the direction. Okay, so the direction also similar, but this one actually one and half from the original the original vector here. If one and half actually, if we convert into the numbers, actually is equals to 1.5, right? One and half, so 1.5. In vector, we need to state in terms of fraction. So instead of 1.5 decimal values, we change into a fraction. So it become 3 over 2a. Okay, it become 3 over 2a. All right. So guys, so far any problem for the vector? Okay, please you may respond on the live chat here if you have a problem. For your information, today just for learning. Okay, just for learning all the important things, and I just want to give you notes. Okay, for today. There's no example, or sorry, there's no calculation on SPM question, whatever. Okay, so now that is our vector. So let me repeat again. So vector actually must have these two things to define a vector. It must have a magnitude and also must have the direction. What is mean by magnitude is a length. You can count the length here. Okay, direction is mean by the arrow given. Okay, for instance here, I have a vector A. You see the direction from left to right, and the magnitude is A. Okay, cacing. I call cacing here. So this is what we call vector. Now, my second line is a double length if you compare with the previous. That's why, and you see the direction here. They are same direction with the previous. So the value of this vector is a 2A cacing. But the third line is a 1.5. 1.5 of the original vector. So 1.5 actually is 1.5. 1.5 we must convert become a fraction, so that we must take 3 over 2a. Okay guys, please be careful. When you want to state the vector, you must look at two things: the value, the magnitude, and also the direction. Can the vector in negative value? Yes. Why vector become negative? Because the direction. That's why not only the magnitude very important, but also direction also sangat penting. Okay, that is number one. Okay guys, okay, seterusnya, let's say I have, okay, let's say what is important about this chapter lagi? Okay, the direction. So just now I mentioned to you the negative vector, right? That means that is involved for the direction. Now we have we already finished talking about the magnitude. So for the direction, it can be positive, it can be negative. And also in in the topic direction, okay, we have, okay, first it can be positive, it can be negative. All right, and also we have most important thing is parallel. Okay, so guys, for direction, it can be positive. How to identify the vector is a positive direction? If A from left to right, all this vector from left to right, right? So that means all the vector is a positive. How the vector become negative direction? If the sign of arrow in the opposite way. Now you see the example here from left to right. If the direction from right to left, Okay, let's say I use this example from the arrow move from right to left, so the vector will become negative A vector. Okay, that is mean by positive and negative direction. Okay, positive direction, you see all the direction on the same direction, so positive. If one of these become different opposite direction, so the vector will become negative. Okay, now let's talk about parallel. What is parallel? You already learned the parallel line before. Okay, in mathematics. Okay, so let's say I have a line like this. Okay, this is my vector A. Okay, so this is my vector A and this is my vector B. Okay, so guys, what is mean by parallel? Parallel means the vector, both these vector have the similar direction. But for your information, the magnitude A and B is not necessarily equal. When we talk about parallel vector, bila kita sebut tentang selari, garis selari, vector selari. Dia vector selari means, ataupun parallel vector means the direction are equal. This is what we call parallel vector. But if you look at the magnitude, is that all the magnitude similar? No, the magnitude is not similar. It's not necessarily similar. Okay, as long the direction are similar, yes, we can conclude this thing is a parallel vector. That's why I labeling as A, this one as a B vector. So what we can conclude here is A is parallel to B. So how we write the parallel? Very straightforward. A vector parallel, double line with vector B. Okay, so that is about parallel. Okay guys, so far ada soalan ke tentang basic vector? Okay, so we already learn the magnitude is about length. We also learn the direction. The magnitude is depends on the length of the vector. So you can find the length of the vector by using this example here, and the direction can be two value, either positive or negative. It depends. If positive, from left to right, left to right, left to right, like this, or if one of this, okay, let's say one of these in the opposite direction, it become negative direction. And for parallel is okay, parallel, important thing is the direction. Is about to define the parallel. As long the direction is similar, so we can conclude these two vector A and B are parallel each other. But please remember, even though these two vectors are parallel, but they are not necessarily have the similar magnitude. Nampak tak sini dia pendek, ni panjang. So they are different magnitude even though they are parallel. Okay. So guys, that is about the basic about direction. Okay. So let me, okay. If I have example, say dalam tajuk ini, let's say I have, this is 3A. Okay. Now, I have a vector. I have a vector from A to B. Okay, from A to B, and then the vector is 3A. Now, what will happen if my direction in the other way? Now, refer back to your direction definition tadi. So now, from A to B, this vector is a 3A. So, if the direction is opposite direction, the vector will become, okay, the vector will becoming negative 3A. All right, it will become negative 3A. All right, so look carefully. The example here, A going to B is a 3A. If they are same line A to B, A and B, but the direction is opposite direction, so the vector will become negative vector. Okay, this is what I mean by negative vector. So how we write in form of vector? Okay, in the form of vector, this is lukisan. So how we write in form of vector? So AB, okay, so actually is equals to Alright, you see here. A vector AB equals to BA, right? The direction. But don't forget, when we talk about opposite direction, we must have negative here. Okay? So, the vector AB actually equals to negative BA. This is how, this is how we write the vector also. From, that means AB is a point A, move A and B, and then the arrow on the top here is moving from A moving to B. Okay, so the vector of AB is 3A, right? 3A cacing here equals to negative BA. Negative BA. BA is negative 3A. So let's prove it. Let's prove this equation. So you see here, AB is a 3A. So the BA, okay, guys. So since the AB is a 3A, this is the identity. This is the identity. You must remember that. Okay. So BA, how much your BA? BA is opposite direction, right? Negative 3A, right? So we just put negative 3A. So you see here, the negative from the formula and the negative value from the BA, they are cancelling each other, become positive 3A again. That is the proof. Why AB equals to negative BA. Okay. Okay guys, so far ada masalah ke soalan macam ni? This is what we call basic vector dulu, the magnitude and the direction. Okay guys, ada problem? Okay, Syamin kata tak ada masalah. Yang lain ada masalah ke? If you have a problem, please state your problem here. We will go through with your problem and discuss, okay, together. Okay, so that is number one about the vector. Okay, so the second things that we need to know about the vector is what you call that? Let's talk about the parallel vector. Okay, collinear. The collinear and parallel. Okay, collinear and parallel. Okay, that's a important tajuk. Okay, so the second thing is, okay, tajuk kedua tadi tajuk pertama settle. Alright, tajuk kedua, let's talk about collinear. Okay, collinear. Okay, collinear vector. Okay, now guys, what is mean by collinear? Is a segaris. Okay, segaris. Okay, so let's say I have a vector A, B, and I have a vector A, B, C like this. Okay, so a point A, a point B, and a point C. Okay, actually this thing you already learned during your what you call it, chapter 6. Chapter 6, if I'm not mistaken, geometry coordinates form 4. Okay, so you learn the makcik nenek, right? The makcik nenek, the ratio here. Okay, let's say I have a vector. Okay, sorry. Let's say I have a point, a ratio. Okay, a ratio. Let's say 2 and 3 here. Okay, right? So I have a point A, B, and C, and then the ratio is 2 and 3 in between A, B, and B, C. Okay, guys. So from here, what is meant by collinear vector? Collinear vector means, all right. So what we can write AB equals to like this. This is what we call collinear vector, where vector AB is equals to lambda vector of BC. Okay, so lambda, what is mean by lambda? Lambda stands for a ratio. It's a numbers. Okay, it's a number or ratio. Okay, so this lambda is very important. This formula, this this formula is very important for you to solve the majority of the question in SPM. Okay, when we talk about collinear vector, normally the soalan very this is tajuk very favorite in SPM, favorable tajuk in SPM. So make sure you know how to work with this formula. So AB is equals to lambda BC. And you must notice that lambda actually is a ratio, is a number. Okay. So from this example here, AB and BC, okay. So AB means the direction A going to be, A going to be. And the direction BC, you see here, the direction also from B to C. Okay. So guys, from this example, I can conclude that AB actually equals to 2 over 3 BC. Okay. This is my example here. AB and BC. So AB vector actually equals to, how I know the lambda is equals to 2 over 3. So I just assume the lambda is 2 over 3 BC. The problem is in SPM, you must determine this 2 over 3. But how? So Soalan SPM normally they give you that like this, the basic like this garisan ataupun in term of story. Then you need to draw the line and put the numbers like this. Okay, and then to solve the problem, the first thing is you need to identify how much the value of lambda. From this my example, my lambda is 2 over 3. So how I get this value? Okay guys, sangat mudah. Now back to basic to form 4. When you form berapa, I don't know which form you learn the ratio, but so how we find this number? Okay guys, so guys, so you see here BC, if I move to the left side, what will happen? It will become, right, it will become divide. So BC here, I move to the left, it become over, right? So AB vector over by BC vector equals to 2 over 3. So from the definition of ratio, okay, we know that ratio state that ratio actually is a fraction, right? So we can make a conclusion here. Therefore, a vector AB to the ratio of vector BC are equals to this one. That's how I know 2 over 3. The lambda is 2 over 3 because you see here, the vector AB ratio to BC equals to 2 ratio 3. You see, 2 and 3, makcik and nenek. This is makcik, this is nenek. Okay, so that's why I know the lambda is 2 over 3. So very important this step. Okay, make sure you know how to find the value, how to solve the lambda here. Okay, before you solve the problem, you must identify your lambda first. Okay, after that, baru you can continue with the formula to solve the problem. Okay, that is number 2 for today. Okay, so far guys, ada masalah? Do you have a problem guys? That is our number 2. Okay, before we proceed to third things, okay, the important things in this chapter. Okay, so far tak ada masalah ya. I hope you guys okay. Alright, so that is number 2. Settle. Okay, let's look at number 3. The third things that we're going to learn for vector is how we write the vector. Okay, I dah tunjuk contoh several example how we write the vector, but now we want to elaborate in that more depth how we write the vector. So let's see how to write vector. Okay guys, okay, let's say I have a vector AB equals to 3, equals to, let's say I use a simple example. Let's say 3A plus 4B. This one. How we write the vector? So let's say I have a vector AB. Vector AB equals to 3A plus 4B. Now, guys, normally don't worry about A and B here. Okay, 3 stand for 3 is a magnitude, right? Okay, A is a vector unit. 4 also is a magnitude. B is a vector unit. Okay, actually A and B here, A stand for x-axis, B stand for y-axis. Okay, vector AB can write in terms of this and also can be write like this. Okay, I'm use the same example. So Okay, don't worry. They are same thing. A actually is a x-axis. B actually is your y-axis. Tak suka macam ni, they also can write in term of this. Ha, 3i plus 4j, cacing. Normally in SPM, I and J the most favorite way. The favorite uh, uh, direction that we use in SPM. Okay, so don't worry about I and J. Actually, I and J, A and B, they are equals to X and Y. Okay, 3i means there is a direction in X for 3i. 4j means there's a direction on Y. Okay, that's a one way. This is the first way we write the vector of AB. Okay, now instead of using the vector form, this is what we call vector form. Okay, so we also can write the AB in the form of, okay, this one. I believe that you very familiar with this form, like a matrix form. Okay, so this form not only like a matrix form, but also, if I'm not mistaken, you learn in mathematics, right? In chapter 3, apa tajuk makcik tu? Apa tu? Transformation. Yeah, the tajuk transformation. You learn this thing. You learn the bracket numbers like this in the matrix form. Okay, this one in that transformation ataupun apa nama Melayu dia tak apa tu? I tak ingat dah. Okay, so ini nama dia. This is what we call translation, right? Translation. Okay, they are same thing actually. So if our 3 is negative 3a plus 4b, so the inside this bracket we must put, let's say I draw on the Cartesian plane. Okay, let's say this is my y, this is x, right? Okay guys, okay, so what is a vector AB? Let's say vector AB says 3a plus 4b, right? What is 3a? A is your x-axis, B is your y-axis. Okay, both of this number is a positive number, right? Positive 3 and positive 4. That means if the number is a positive 3 like this, that means we move 3 times on x-axis to the right side. If the number of A here is negative 3, that means we move backward. We move to the left side 3 times, okay, on the x-axis. Okay, for positive 4 here, positive 4 here means we are moving 4 times to the top. Okay, we jump 4 times to top based okay, on the y-axis. And if the 4 is negative, we go down 4 times. Okay, that's what is positive and negative means. Okay, so I'm using the same example, 3i plus 4j here. Okay, so 3i 1 2 3, okay, and the 4j 1 2 3 4. Okay, so 3i, that means we jump 3 times, 1 2 3. Why I jump to the right? Because the value is a positive, so I jump 3 times. And 4j, that means it's a positive value, so I jump 4 times to the top. So for jumping here, so what we can do is, okay, we just connect the dot, so it will become, okay, so it will become like this. This is the vector. Okay, so this is a 3, this is 4, and this is the vector AB. Okay, so here the vector AB actually is 3 to the right and 4 on your to the top. Okay, 4 times jumping to top, okay, to the top, because it's a positive value. So we just draw the line A going to be the direction, because from A going to B, so this is the diagram. Okay, so we got 3 ways to write the vector: in the vector form, in the bracket, in the matrix method, and also in the Cartesian method. Okay, so That is how we write the vector. Okay, guys. Just now I'm talking about all the value is positive, right? How about if one of the value or both of value is negative? Okay, let's say I have a vector CD, CD equals to, let's say, 3i minus 4j. Okay, I have this vector CD equals to 3i minus 4j. Okay, 3i minus 4j. Okay, so how to write this vector? Sangat mudah. 3i maksudnya we move 3 times. We move 3 times on the x-axis to the right. And negative 4j, we are moving downwards. Okay, we're moving down. We jump 4 times. Okay, we jump 4 times. So, we can draw that. Okay, let's say I draw on the second quadrant. On the second quadrant. So, that means for CD, 3i. Okay, 3i, I'm moving 3 times to the right. Okay, and 4j, I'm moving downwards 4 times. Okay, you see here, I just draw on the second quadrant. So the CD is 3i. 3i means I move from left to right 3 times. Okay, 3 times. You see the arrow here, just underneath the 3. And the negative 4j means I move downwards 4 times. That's why you see the direction moving downwards. Okay, so we need to draw the line of vector CD. So just connect and put the direction CD. Okay, that is your vector CD. Okay, CD. Okay, guys, that is second example. Okay, now how about the third example? Let's say I have both of my value vector is negative, negative A and negative B. Let's say I have vector EF equals to negative 7i minus 2j. Look, contoh, contoh. Okay, this is my example. Okay, so my vector EF negative 7i minus 2j. So how we draw this makcik in our Cartesian plane? Okay, let's say because first quadrant, second quadrant sudah ada gambar. So let's say on your fourth quadrant, we draw this vector, fourth quadrant. What is mean by negative 7i? I and j stand for x-axis and y-axis, so don't worry. Okay, they are similar for A and B, X and Y doesn't matter. So now, negative 7i means we are moving 7 times, we jump 7 times from right to left, okay, from right to left. And the meaning of negative 2j means we going downwards 2 times. So, we just draw the line first, okay, the line of EF, negative 7, negative 7. Sorry, I want to draw on the fourth quadrant, So negative 7, and 2j. So we move down to here. Okay, you see, this is the example here. Okay, so EF negative 7, that means we move from right to left 7 times, we jump. So you see the direction right to left, that's why it's a negative. And the negative 2j, that means we're going downwards 2 times. We jump 2 times, going downwards. Okay, so we connect this vector. So it will form, normally when we connect the vector, it always form a triangle. Okay, it's always form the right angle triangle. So you see here, EF. Okay, you see here, this is our vector here, EF. The direction from, okay, I want to find the vector of EF, so I need to draw E to this point 7 times because it's a negative. That means it moves from right to left, and from this point going downwards 2 times because it's a negative 2. Okay, so this is how we write the vector. So let me repeat again. We can write the vector in the form of vector form, or we can write the vector in matrix method. Or also we can write the vector in the form of Cartesian, on the Cartesian plane. Okay, that means we need to draw the vector. Okay, so guys, do you have a problem for our third lesson of the day? Okay, kita can today my purpose is I just want to give you the introduction, the whole thing about vector. Okay, no calculation at all for today. Okay, next class I will show you example in SPM question, the real SPM question, paper 1 and paper 2, then we solve together. Okay, so this is our third lesson of the day. Alright, so guys, ada masalah atau tidak? Okay, boleh respon please respond on the live chat. Okay, so bila tak respon ni I risau sikit. Okay, I big apa ni, bukan nervous, risau, okay, because of takut you guys have a problem maybe. Okay, so if you have a problem, then we can proceed to the next topic. Okay, so hari ni kelas memang short saja, ringkas saja. Okay, very short time saja untuk for today. Okay, Angel. Okay, so no problem. Okay, so if Angel doesn't have a problem, that means I assume every one of you doesn't have a problem too. Okay, guys, that is our third lesson. And now, okay. So the next thing I want to discuss with you is, okay, the origin of vector, origin. Okay, how to relate the origin with a vector? Okay, relationship. Okay, relationship between origin and vector. Okay, so guys, okay, yeah, okay, this is y and x, this is origin. Okay, guys, now our fourth lesson, 1 2 3 4, yeah, this is the fourth lesson for today. For okay, so how we relate, what's the relationship between this origin and the vector? Okay, we know that a vector can be written in A, B, C, D, E, F, whatever. Let's say I have a vector AB. Okay, vector AB. Okay, vector AB. Okay, I have a vector AB. Now, I draw the vector AB on my Cartesian plane. Okay, let's say I draw in this side. Okay, this is A, this is B. Okay, so this is a second quadrant, second quadrant. So my vector AB here, and don't forget the direction from A going to B. You see the direction A going to B. Okay, so AB, how to find the vector of AB? By using the origin. Okay, by using the origin. So that's mean I told you, if you still remember, if we want to solve the problem involving vector, when we sketch on the Cartesian plane, it always produce a triangle. It's not necessarily right angle triangle. Sorry for that mistake. It can be, it must form normally it can form a right, it can form a triangle. Not necessarily triangle, but also it can form other what we call that, what we call that, diagram. Okay, it's a square also can be formed. Okay, apa nama makcik tu kita panggil polygon. Okay, it can form polygon. Okay, so one of the simple polygon that can form by drawing the vector is a triangle. So now, how we relate the coordinate 0 here, the origin with vector AB? Okay, so if we connect, okay, oops, tak cantik. Okay, now guys, if you look here, I connect the vector AB. Okay, I want to find the AB here, so I connect A to O and then O to B here. There's a line OA and OB here, right? So to find the vector AB, okay, actually is equals to, okay guys, to find the vector AB, actually is equals to AO plus OB. Okay, you nak dapatkan vector AB, you must start from A going to from A going to O, and then from O going to B. So you see the direction from AO and then OB. You must draw the direction here. So AO, OB. This is the formula. Okay. So if you want to find AB, you see here A and B, hujung and hujung. Okay, the first value and the ending of huruf here. In the middle, between both vector, they have similar huruf, which is O and O. Actually, O and O, they are cancelling, and then it becomes AB again. Okay, so if I have a vector, let's say, I have a vector, let's say, CD. Okay, contoh, this one. I have a vector C and D, but the direction is moving from D to C. So the vector DC, the vector DC. So how I form the formula? How I form this formula to find the vector of DC? By relate the formula with the origin. So what you need to do is just connect this C and D to this origin. It will form a triangle. So we connect. Okay. You see here, we want to find C and we want to find DC, right? DC. So what we can do is it will become, right? So I want to find DC. Like my previous example, I want to find AB equals to AO plus OB. So my DC, my starting huruf must be D, but my ending huruf must be C. Alhamdulillah. But what is the huruf in front of the D and the back of C here? So it must be O, origin. Okay, and both of huruf must be equal huruf, similar huruf, so that they can cancel each other. Okay, so the huruf here is O and O. Okay, the huruf is O and O. Okay, that's how you find the vector of DC. That means you want to find the vector DC, you must move the D to O. Okay, the D going to O and O going, the D going to O and O going to C. So that is how you solve the problem. Okay, guys, do you have a problem for the vector? How we relate the vector with origin? So you need, when we talk about origin, that means you need to form a formula like this. Okay, the formula. Okay, but you must notice that it's not necessary origin as our connection between these two vectors. But also, let's say I have a point D E F E F G E F and G. Okay, I want to find the vector EG. Okay. So guys, let's say if we have a soalan given that the coordinate E, F, and G. Okay, I want to find the vector of EG. That means from E going to G, right? How we form the formula? By using these three coordinates given. Okay, sangat mudah. That means E and G, you just write down like D and C tadi, D and C. So, it become E plus something G. Okay, E and G. So what is the other huruf we need to fill in here? So D, E and G we already use here. So we have another huruf which is F. So just write down your F here. So it will become like this. Okay, so it will become like this. So you want to find the vector EG from the given point E, F, and G. So you must relate all the point. You must connect all the point to find this vector. So to find EG, E your first huruf and G is your final huruf, and the middle between these two must be the other huruf. If from the example we don't have huruf origin here, right? Oh, we don't have O, but we have huruf F. So we must use this F. So that's why EF plus FG to find the EG, settle. Okay, if I draw this makcik on this Cartesian plane, it will become like this. Let's say EFG, E, F, and G. Okay, so I just connect all the E, F, and G. Okay, guys, I want to find this EG. I want to find the vector of EG, right? E going to G. You see the direction here. So to find the EG, I move the E to F, and then from F going to G. So that's how you find EG. Okay. So the direction, don't forget to update. Okay. So you need to draw the direction also. Okay, that is the fourth lesson of the day. So far, any problem, guys? Untuk what we call that? How we relate the point ataupun the origin with the vector. Okay, so that is question number 4. If you have a problem, please state your problem in our live chat. Okay, Afi also no problem. Okay, good. Alright, so that is number 4. Okay, what's the most okay, selain daripada ni apa lagi okay, let's say we have okay, let's talk about how to find a vector. Okay, how to find the vector. Let's say I have a diagram like more complicated. So let's say just now we have all the contour is a triangle, right? So let's say I have a octagon. Octagon. This is my octagon here. Okay, octagon. Okay, so okay, let me remind you again. The vector not necessarily can be formed in can form a triangle, but also it can form another polygon. Let's say this is what we call one of the polygon here. This is what we call octagon. Okay, let's say we label all the point A, B, C, D, E, F, G, H. H. Okay. Okay, guys, this is my my octagon with labeling A, B, C until H. Okay, now my question is I want to find AB. Let's say I want to find the vector AB. So how do we find the vector AB here? AB. To find the vector AB here. So I told you if you want to find the vector, it must produce a closed shape. That means from A going to B, you want to find this vector, so you must move from your A, move to this H, and rotate until the final is going to B. So that means you must write down your formula A dot at the end plus B. Okay, this is your formula actually. The vector A going to be AB actually equals to vector A something plus blah 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 plus something B, and the end on the starting huruf must be similar huruf with the vector itself. So A and B. Now you need to think how I can find the vector A going to B. So the first thing is must be A going to H, right? Okay, so is equals to A going to H plus H G F E B D C and C B. You see here, this is how we solve the problem if we have this kind of diagram. I want to find the vector AB. Now, to find the vector AB, it must be form a closed shape. Okay, to find the vector like this, right? I want to find the vector AB is equal to AO plus OB. Vector AB, it must produce a closed shape. Enclosed shape. Tertutup, gambar tertutup. So now, for A going to B, so I must start from A to H. A going to H, H going to G, G going to F, F going to E, blah, 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 blah. You see here, the huruf in the middle, H, they are cancelling. And then G, they are cancelling. F, cancelling. E, cancelling. D, cancelling. C, cancelling. So what is the huruf left here? A and B. That's why the formula A and B is must be start from the first huruf must be huruf A, but the ending huruf must end with the huruf B. Okay, that is the first thing we need to know about this diagram. Number two, if you look our previous notes, we are talking about parallel, right? We are talking about parallel vector. Okay, guys, from here, okay, from this diagram also, we can conclude, we can make a conclusion that my diagram is not follow the scale. So assume what we call that? My diagram is a regular shape. Okay, this is a regular octagon. So now AB and apa nama ni? GF. Okay, AB and FE, they are actually parallel each other. Okay, so vector AB and the vector FE, they are actually parallel each other. Okay, they are parallel each other, right? That is first conclusion we can make. Number two, not only they are parallel each other, but also they are same vector, similar vector, which is if my vector AB is A, so the vector of FE also A. Why? Because they are same length. Actually, they are same length. My diagram, don't please assume that my diagram is a regular octagon. So this length and this length also similar length. Okay. So that's why if this vector is A, this one also A. The direction also parallel. So we can make two conclusions here. AB are parallel with FE, and the vector, both of them are equal vector. This is what we call equal vector. There's one more thing you need to know about vector. This one we tambah satu lagi, equal vector. Okay, equal vector. What is equal vector? Equal vector means the magnitude value are similar. This one is A, bawah ini juga A, so they are equal vector. Okay. So guys, contoh tadi yang inilah. Okay. This one, A going to be is a vector A, and F and G also is a vector A. So they are equal vector. Not only they are parallel, but also equal. Okay, that is our fourth lesson of the day. So guys, ada apa-apa masalah before kita masuk next? Ada soalan ke? Okay. Ada apa-apa soalan nak tanya so far? Okay, hopefully tak ada masalah Okay, so that is number 4 and number 5. Okay, I think number 5 will be the last one. Okay, number 5. I told you to form a vector, to find the value of vector. If we draw the vector, it always form an enclosed shape, right? So the most the most famous enclosed shape is either triangle or rectangle. Okay, macam itu dua sajalah yang selalunya. Okay, let's say I have this kind of soal, this kind of vector. Let's say. Okay. Okay guys, I have this shape A, B, mana A? A, B, okay, A, B, C, D. Okay guys, so if the vector AB is given by A and vector AD is given by B vector, okay, so you see here, the AB, the vector is given by A and the vector AD is given by B. So how do we find the vector AC? Okay, My question is, I want to find the vector AC here. Okay, I put double line there. So this one, I want to find the vector AC. Okay, AC, right? So there's several ways to solve the problem. Okay, so the first way is, if I want to find A going to C, A going to C, so we just write AC. If you still remember, I told you just previous our lesson, we must write AC equals to A something plus something C, right? A the starting number and the C is the end of huruf. Sorry, the starting huruf and ending end of huruf. So what's the huruf we must put in the between of these two A and C? It must be equal huruf, right? So I want to find A going to C. So how about AD DC, right? Same direction, right? The huruf are similar, right? A going to D, D going to C. So we can just write AD DC. Okay, AD plus DC. Okay, it also can be right. AC also can be right if I use the different direction. Let's say my direction is AB. So it will AB plus BC, right? AB plus BC. You see here, there's a several way to write down your vector. So the first what we call it, the first method is we just write down the A going to D and D going to C, and also we can use the different direction, which is A going to B going to C. Okay, now this is not the final answer, both of them. So the final answer is, you see here, AB. Okay, if I'm use this one, the yang atas sekali, AB, A donkey. A donkey, what's the vector of A donkey? Okay, so the vector of A donkey is a B vector. Okay, the vector is B. And then plus DC. DC, we don't have a vector, right, for DC, but you must notice that DC and DC and AB, they are parallel each other. Okay, they are parallel each other and also equal vector. You see the length and this length, they are same length. That's why DC, even though we don't have the value, but we can replace the DC with AB. Okay, so it also become AB vector, so it become B plus A. Okay, so don't worry. Okay, even though we don't have the value of DC, but DC actually parallel with AB. That's why DC can change become AB. So the value of AB actually is the vector A. Very straightforward. Okay, how about the second AC? Okay, the second formula. The second formula, you see here, the second formula, I'm using AB as my first direction. AB, which is the vector given is A. Okay, so A. Now, BC, we don't have the vector of BC, but we know that BC and A donkey, they are both equal and parallel vector. Alhamdulillah. So BC here also equals to A donkey. So A vector plus BC, plus A donkey. Okay, A donkey, which is A donkey are actually equals to vector B. So now you see here, the blue color and the red color, both of them give us the similar answer, even though the susunan, the arrangement of the vector are opposite direction, but both of them have the similar magnitude and similar direction. So B plus A vector are equals to vector A plus vector B. Both of these are same. Okay, guys, that is our, I think this is the final for today. Okay, so very shortcut for today. This is all about chapter 4. Chapter vector. Okay, so let me revise, let me repeat again the most important part of this topic. Okay, So first thing is, okay, kita susun dulu mana all about introduction to, oops, alamak, connection is unstable. Okay, connection balik. Okay, sorry, connection tadi unstable. Okay guys, let me recap balik what is the most important about this chapter. Now we already finished that. So number one, you must know the vector must consist of these two things, magnitude and the direction. Magnitude means the length, okay, and the direction, it can be positive and negative, okay. So and this direction also is must have a parallel direction and, okay, a parallel direction. Parallel is very important, parallel and collinear, very important, okay. So guys, the first basic rules you need to know is, if our vector is negative, let's say, so AB vector is equals to negative BA vector. So this is the first identity you need to understand. And also in this topic, we already also learn equal vector. Equal vector means, okay, this example diagram here I showing you is they are parallel vector but not equal vector. Equal vector means they have similar magnitude of vector. Okay, that is what we call equal vector. Okay, this one is not equal vector but parallel each other. Okay, so that is first topic. And the second lesson for today is what we this is the most important. Majority of the soalan SPM will use this formula to solve the problem. Oh yeah, one more thing I forgot. The first, oh, that one will be the third. Okay, later, later. The second thing for this chapter is collinear vector. Collinear means, okay, all the A, B, and C is on the same line, and the ratio is given like this. So to solve the problem, you must know that vector AB equals to lambda BC. Lambda stand for ratio or a numbers. Okay, how to find that ratio? This is how I find the ratio. How I know this is 2/3 ratio? The lambda is equal to 2/3 because this is the proof. When we remove the BC to the right left side, it becomes over. So AB is 2, BC is 3. So when this one we change into a ratio, it becomes AB ratio to BC equals to 2 ratio to 3. 2 ratio and 3. Makcik nenek. This one you also learn during your form 4. Okay, so please make your revision in form 4 punya topic. Okay, now the third things. Okay, third, we learn how to write the vector. Okay guys, I just remember one most important tajuk in this number 3. Okay, let me go through this first and then we jump to that tajuk. Okay, how we write the vector? Very easy. Vector can be write in the 3 ways. Number 1, in a vector form. Number 2, matrix form. Number 3, Cartesian plane. So to draw the to write in the vector form, it can be let's say I have a 3a vector plus 4b. This is my vector AB, 3a plus 4b cacing. Okay, A and B represent the vector unit. So don't worry. A and B actually represent similar like X and Y. Okay, paksi X and paksi Y here. I and A also can be used to sometimes. So if you have this kind of question, so don't worry. I, J, A, B actually they are equals to X and Y. Okay, so this is my first way to write down the vector AB. So I also can write down in the matrix form, what we call this a translation form. Positive 3 and positive 4, so 3 and 4. On the top must be A vector, bottom must be B vector, or X vector, Y vector, or I vector, J vector at the bottom. Okay, so this is the third way to represent the vector by drawing. So this is a 3 example here. So this is my 3 example question. So this is how I draw. If our value, let's say 3i, that means positive 3, they are moving from left to right on the x-axis. Okay, left to right. Okay, and then 4j, that means they are moving top. They are moving to the top. So 4 times, they jump 4 times to the top. So jump 4 kali, then we connect the line A going to be like this. So they goes to this method also similar to the second and third example here. Okay, If one of the huruf or both of numbers is negative, so please be careful the direction. The negative means if on the x-axis it will move from right to left. If on the y-axis it will move from the top to the bottom. Okay, so that is represented by negative vector. Okay, so the things that I just now remember is, okay, additional for 3, how to find the vector unit, and also how to find the vector, how to find the magnitude of vector and how to find the vector unit. Okay, so now let's say this is my vector AB. I'm use this example. Okay, so my next topic is, okay, magnitude. Okay, let's say my vector AB equals to 3i plus 4j. Okay, this is my vector AB equals to 3i plus 4j. How to find the magnitude of AB? To find the magnitude, you must remember the symbol of magnitude is like this. Okay, this is the symbol of magnitude of vector AB. A modulus AB vector. Okay, to find the magnitude, very easy. Okay, I told you, sangat mudah. Okay, just use your theorem Pythagoras method. That means we square the 3, we square the 4, and we plus both and square root. So that's how we find the magnitude. So 3 squared plus 4 squared square root, then we supposed to get jawapannya berapa? 5. So magnitude of AB, okay, the magnitude of vector AB, 3i plus 4j, are equals to 5. 3 squared plus 4 squared, square root, get 5. If our value is, let's say negative 7i minus 2j, just square the negative 7 squared plus negative 2 squared. When you square the negative number, it will become positive. Please always remember that. So when you square 97, the plus with square of negative 2, then you total up, then you do the square root, then you get the final answer. That is your magnitude for EF. Okay, the magnitude for AB equals to 5. All right, and after we find the magnitude, we want to find the vector unit. Vector unit of AB equals to like this. Okay, this is the symbol of vector unit. AB macam ni, ada topi kat atas. Okay, so the vector unit of vector AB equals to AB topi. Okay, so how we find the vector unit? Vector unit equals to the vector over by the magnitude of vector. So that is the formula. The vector unit AB equals to the vector of AB over by the magnitude of that vector. So look at your vector. Your vector is 3i plus 4j, right? Just write your vector 3i plus 4j. Okay, this is your vector over by what? Over by your magnitude. That's why you count the magnitude first before you write your vector unit. So divided by 5, so over by 5. So over by 5, both of the vectors. So 3i over 5 plus 4j over by 5. That is your vector unit of AB. Okay guys, hopefully you guys found. This is the additional. Please jot down this thing. Okay, that is the third lesson, how we write the vector. Okay, so in this topic, we learn how to write down the vector in 3 ways. Okay, in 3 ways. And also, we also learn how to find the magnitude and to write down the vector unit of the vector AB. Okay, that will be number 3. Okay, so far ada masalah? Hopefully tak ada masalah. Okay, so that is number 3. Number 4 now. Okay, we still 2 more. Okay, number 4, we want to find the relationship between the origin and the vector. Normally, vector is from the coordinates. Okay, A and B. Let's say we have a vector A and B. A and B actually both of them are point, right? Point, that means when we talk about point, they have a coordinates. Okay, so now how to find the relationship between this AB and 0 and the origin? So we just connect AO and OB, then it will form a triangle. It form a triangle. Okay, so it's so also similar goes to DC. It also a triangle, and also yang ini the third example here. Okay, okay, now guys, now after we form a triangle, so we want to write down the formula. So to find the AB, actually is equals to A something plus something B. The first huruf and ending huruf must equals to our vector A and B. So in the middle between here, A must have the similar huruf, which is 0, 0, or origin O, because because after when we write down like this, they are cancelling each other. The O and O here will be cancelling, then A and B can together become the AB vector. That's how we form the formula from by using the origin. Okay, similar like DC. How to find the DC here? We going to see DO plus OC. O and O, they are same huruf. They can cancel each other, then it become DC. Okay, it's similar like EFG. EFG here. EFG means, let's say we are not using origin as our third coordinate, but we use F as our third coordinates. So I want to find E and G. So F repeated. Okay. So this is my next lesson. If we have this kind of diagram, I told you I want to find A and B. This is the direction. Okay. So I want to find A to B, then the direction will be like this. And also in this topic, we also learn equal vector. AB and AF apa ni? FE is a equal vector. Okay, you may repeat again nanti. So then the last one here. So I want to find the vector AC. So AD plus DC ataupun AB plus BC. This is how we solve the problem. Okay, so that will be the end of our class, and I believe we already covered everything in the topic of vector, all the basic. Okay, all the basic. So the next class I will discuss with you how to solve the problem involving vector, especially when we especially in paper 1 and paper 2. So but the next class will be paper 1. We focus on paper 1 only, and the following class we will focus on paper 2. Okay, so if you don't have any, if you have a problem, please leave a comment ataupun live chat here. So I will go through your problem, ataupun you can personally WhatsApp me. Okay, so I hope you guys make your own recap. So that will be the end of our class for today. Okay guys, stay safe. Have a good holiday. Okay, goodbye.